What's up, everybody? You're on GCSE and iGCSE. This is revision with Daniel Dallas. Alright, so we gotta go through circle theorems. This is medium, maybe hard level for someone. Make sure you watch medium level and easy stuff. There are plenty in the playlist. And we gotta start. So here's the problem. You have the circle, you have inscribed angle ACB, you have central angle AOB. So try to pause the video, try to do by your own, and let's have a look at my explanation. Alright, so we're gonna answer the first question. We need to find out whether triangle AOB is equilateral, and we need to prove that. Okay, so let's have a look. So we basically connect with the chord. Let's connect with the chord A, 2 points A and B. That's going to be chord, so that we can arrange triangle AOB. And let's input some angles, because we definitely need to figure out not from sides points but from the angles points. So we need to prove basically that each angle within triangle AOB is 60 degrees. Alright, so let's mark angle Y here, angle Y here as well. Why? Because AOR and OB are radii, so we can mark AOR equals OB because as radii of the circle, you understand that radius is basically the line segment connecting a point on the circumference, any point on the circumference with the center. So that means they're equal to R, which is the radius in that case, and that means they're equal. So at least this triangle is equilateral, is isosceles, so that means two angles A and B at those vertices are Y and they both equal. Okay, so hence we have two angles the same. But what about angle AOB? So AOB is the central angle, so that means we can figure out and connect with inscribed angle ACB. So ACB is 30 degrees, so that angle is twice more. That's why it's 60 degrees, because it's obtained by the same arc length AB. It's right there. All right, so we figure out, and let's complete the sum of all three angles. So Y and Y means 2Y and 60 degrees. Together we'll arrange 180 degrees. So from there, we can figure out this 120 over 2. That means it's 60 degrees stays for Y. Because they're both Y's, well, we have all three angles 60 degrees, and that means this triangle is equilateral. So A is done. Let's go to B. Have a look at B1. So in question B, we are asked what is the measure for angle CAO. Let's have a look. CAO. Let's mark this angle as, let's say, X. Let it be this angle as X. So this angle is X degrees. Okay, and what we can do, we can consider triangle ABC, the big one. Let's consider triangle ABC, and let's complete the sum of all three angles. So angle A represented by X plus Y. That's angle A. So here is angle A. Next, we add angle B, which is represented by Y and 15 degrees. So it's going to be Y plus 15 degrees. That's going to be angle B. And let's add up angle C, which is 30 degrees. So all three angles should form 180 degrees. And because we know Y from the previous question, we can plug in and let's complete the equation from in respect for X. So we need to solve that for X, and that means we have X. So 2 Y's will give you 120. On top of that, we need to add 15 and 30, so it means 45, and that will arrange 180. Alright, so if we subtract, we'll get 60, and 60 minus 45, we'll get 15 degrees. So we've got angle X as 15 degrees, and we worked out angle So CAO. CAO hence will be equal to 15 degrees. All right, so in the last question, if the radius of the circle R equals to 15 centimeters, what is the area of triangle AOB? All right, let's have a look there. I think I can complete still on that slide. And let's do C. So C part. You remember the formula, how to find the area of triangle. So it's all about using height in the triangle. But because we're given two sides, we can do it a bit different way. So I'll show you for random triangle. Make sure you remember that. For any scaling triangle it works. So if you have two sides and angle between them, let's say alpha, so the area of the triangle can also be calculated as 1/2 A times B and times sine of the angle in between them. All right, so we're going to use this fact because we are given radii, right? So we are given two radii in that case. So we can use this fact, and in our case 15 and 15, area for the triangle AOB is going to be 1/2, so radii, basically r squared, and times sine of the angle in between, that means sine 60. Instead of radius, we put 15, so we've got 15 times itself and times sine of 60 and over 2. Now let's get calculated. So 15 and 15, 225. Then we've got sine 60. Sine 60 is square root of 3/2. And that means we've got square root of 3/4. And that's going to be the final formula for the area. So this is the area. All right, hope you enjoyed that. That was pretty easy, but we answered pretty diverse questions dedicated to circle theorems, and also we touch barely areas of the triangles. All right, hope you like that. Don't forget to subscribe if you're new here, and peace out.